Hi everyone. Thank you for logging on for your Algebra 1 lesson for the week. This is Mrs. Lester and I'm going to spend hopefully no more than maybe 20 minutes or so talking to you about dot plots and histograms. So in your last lesson, Miss Tidings gave you a video regarding univariate statistics, things like the mean, the median, the mode, the range, and the standard deviation, things like that. So those are statistical measures that we can calculate from a set of data. And now what we're going to do today is talk about how we can graph the data and use the graph to interpret it a little bit more. So it says data tells a story and are often summarized by graphs. Graphs provide a representation of the data distribution and are used to understand the data and to answer questions about the distribution. So that is our goal today, is not only how to make these two types of graphs, dot plots and histograms, but then also what we can interpret from those. So the two types of graphs that we, the two types of graphs that we are going to focus on are dot plots and histograms. And I do think you probably did both of these back in middle school, so this shouldn't be any new surprise. So a dot plot is a plot of each data value on a scale or number line. So if you look down below, I'm gonna circle my dot plots or box them in this blue color. So these are examples of what dot plots look like. Okay, I think there's probably maybe another one. Nope, okay. So those are what the dot plot looks like. You just put one dot for each data value on a number line. And then the other type we're going to focus on are histograms, which is a graph of data that groups the data based on intervals and represents the data in each interval by a bar. The height of the bar represents the frequency of data values in that interval. So you'll see kind of what they're talking about with these intervals when we start to do the examples. You can't really see the intervals on these pictures, but just so that you keep the two straight, the histogram is the one that looks similar to a bar graph that you may have done even in elementary school. Okay? Pretty simple to keep the two straight. So the things that we want to make sure that we can interpret from these types of graphs are listed here in this box called vocabulary. So the first thing that's going to be really important for us to understand and interpret is what's called the shape of the data distribution. And there's lots of different types of shapes that the data can take, but we're going to mainly focus on two types. So the first type is a symmetric distribution. And if you think about what the word symmetric means, we know that if something is symmetric, it's equal or the same on both sides. So down below it says, in a symmetric distribution, a vertical line can be drawn and the result is a graph divided in two parts that are approximate mirror images of each other. So I'm going to underline that part. So in a symmetric data, I should be able to draw a vertical line and the two sides would roughly be the same. Now I know in my examples up here, if I draw the middle of this one, you can see sometimes the middle goes through the data like a bar, and sometimes it's in between. It can be either way. Sometimes the two sides are identical, like they are on these two examples, but just know that it only has to be an approximate mirror image. Okay, the other type, which is a little bit harder to understand, is what's called a skewed distribution. So it says in a skewed distribution, oh, I think that's a typo, but that's okay. A distribution may be skewed to the right or skewed to the left. This means the cluster of the data falls on one side and a tail is formed on the other side. So a cluster is on one side and a tail is on the other. So this is how I tell kids to know if a data set is skewed. If you were to draw a line that connected the tops of your data, if one side there is what we would call like a tail that's longer than the other side, then that would mean the data is skewed. And the way that we decide if it's left or right is based on the tail. So this example up here is going to be skewed. Let's see, what direction is this tail? This direction is to the right. And if I come over on this guy and I connect all the tops of those bars, the bars formed by the dots, I see the tail is on the left. So this is what's called left, oops, sorry about that, left skewed, or skewed left, I should say. Skewed means being pulled in that direction. The cluster is on the opposite side, and then the data is being pulled just a little in the other direction by some kind of stragglers. All right, let's see what other vocab we have here. So we also have the center. That's where most of the data falls. The location is roughly half of the values are below, and half the values are above. When we define it that way, kids always think of it as the median, but just remember from your last lesson that we learned there's different measures of center. So the center could be referring to the mean, the median, or the mode. The spread refers to how spread out the data is. And another word we use for spread is variability. So if the range is really big or the standard deviation is really big, then we say the data has a lot of variability or a large variability. The peak is pretty self-explanatory. That's going to be where the majority of the data falls. So it's also going to represent the mode. There could be two peaks or two modes. That has a fun name, bimodal, because that prefix bi means two. And you know from the last lesson, you could have 3 modes, 5 modes, you could have no mode. So you won't always have a peak, and you might have more than one peak. Again, from the last lesson, an outlier is an observation that lies an abnormal distance from the other values in a sample. Usually after a gap in the data, so like a space. So if you look at these examples, I would say there are no outliers because there isn't like a break in the data and then this one random point by itself. If, say, this number line went out here to 20 and there was a dot over there, that would be an example of an outlier, right? It's way bigger than all the rest of the data. All right, and then the last one here is a cluster. And I think that's pretty self-explanatory. That's where the group of the data falls. So kind of like if you were going to say this is where most of the data is between here and here, we call that a cluster. All right, so example A and B, we are just going to describe the shape, the center, and spread. And this is very objective. There's different ways, did I use the wrong word? Subjective, I should say. There's definitely different ways we could interpret this. The shape usually has one correct answer. The center is going to vary a little from student to student, and the same with what a student might say for the spread. So here's what I mean. So on this first set of data, in order to determine the shape, again, I like to connect the top of the dots or the bars and then decide if it's approximately symmetric. Does it look the same on both sides roughly? Or is there clearly a much longer tail on one side versus the other? So I see a longer tail over here on the left, So the shape of this distribution is going to be skewed left. Okay, the next thing wants the center. Now I know some of you exact perfectionist type will probably find the exact median, the exact middle number. That might be okay for most of them, but it doesn't have to be exact, just so you know. You're just approximating these things. So what I do is I look at where there is a cluster of most of the data, and then I just find roughly the middle of that. So for me, I'm going to say this center is roughly at 7. Again, it's gray area. I would say if you said 6 or 6.5 even, that would probably be okay. The 8, I think, is going to be a little too high because clearly there's not that many points on the other side of the 8. 4 or 5, I would say, is getting a little bit too low, right? There's a lot more points above it. So roughly around that 6 or 7 would be great. And then the last one is we are going to talk about the spread. And later in Algebra 2, they'll want you to really get specific about the standard deviation and all those kind of things. But I'm going to say for us, we're just going to look at the context of the problem and decide if we think that's really spread out based on the context or not very spread out. So it says these numbers are the number of attempts to make a foul shot. So maybe these are all the players on the basketball team, right? And some kids, it only takes one attempt. They pretty much always get it on the first try. Some kids takes 2 attempts, 3 attempts, 4 attempts. And we got kids taking 6, 7, and 8. So think about this in a basketball practice. If we were all sitting there and practicing, would we think all those kids are roughly about the same in terms of their ability to shoot that foul shot? Or would we say there's a lot of variability between their ability to do it, right? A lot of kids are taking 6, 7, and 8. Then you got these couple kids who do it on the first try. So I would say that this is a high or a large variability. Now remember, you have to take it into context of the problem. That does not mean 0 to 9 or 1 to 9 is always a big spread or a large variability. In terms of basketball shots, that's a big difference between kids. Okay? All right, let's look at this example B. I know I'm rambling on, and some of you are like, get to the point, Lester. Okay, let's do the shape. So we take the top and we connect them, and we decide what we think we want to call that. Now I know, like, I'm not hitting them all because it would be kind of goosey if I did, right? I'm going to let you think about that for a second. Then you are going to roughly find the center. And then we're going to decide if we think this data is very spread out, which means high variability, or not too spread out, which is a low or a small variability or spread. All right, so first the shape. So if I look at this thing, would you say that one side has a longer tail than the other? Or would you say they are roughly mirror images? Yeah, I would say those are roughly mirror images of each other. So this guy is a symmetric shape. So then the center is pretty easy to find. If you're roughly the same on both sides, then the center is going to be right in the middle. So this is 3,500. And then we have the spread. So that one will always be the trickiest to figure out. This is about population. So maybe this is the population in a city. if the population is ranging from whatever this guy is, close to 34,000 to just a little past 36,000, in terms of city population, oh, not thousand, I apologize, 3,400 and 3,600. We're roughly around the difference of 200 people. So if we think about when we compare populations, I don't know if we would say that's a very big difference, right? If we were comparing the population of Fairport to Penfield and we said there's roughly 200 more people in Fairport. I'm just making this up, I don't know. That would be, they're pretty close, they're pretty comparable, right? I think for populations, we'd want to see a much bigger difference to say that there's a high variability. So I'm going to say this is a low variability or low or small spread. Got to write with my finger on here because I lost my pen. All right, so the good news is that was the hardest part of the lesson. Now we got the easy stuff. So we are going to make a dot plot and make a histogram and then answer a couple questions about it. So I'm pretty sure you probably remember how to make a dot plot from the past. If not, it's very easy to do. So a random sample of teenagers ages 13 and 14 were asked on average, how many text messages do you send per day? And here are the results. So I helped us out by putting them in order. What you're going to do is come over to your number line, and I just pick a little bit of a distance. It doesn't matter how high you go. I think I might actually try to do this with this guy if I can. I don't know. Let's see. All right. I had to pause for a second there. I was trying to see if I could do it with the dot tool, but it's just not liking me. So we're just going to go the old-fashioned way. I'm going to scribble on here. All right. So what you're going to do is you're going to put one dot for the 0. And then you're going to notice I crossed them out because you don't want to lose your spot. Then I see that I have 1, 2, 3, 4 tens. So I'm going to try to equally space them. And you can see they're not great because I'm using the tip of my finger. But you would try to put some nice dots. So 1, 2, 3, 4. Then I see 1, 2, 3 20s. So again, I try to equally space them. So the 3 should be across from the 3 on the 10. Then I see 1 30. I see 2 40s. I see 1 50. I see 1 70, 1 80, and 1 100. All right. So the first thing it says is approximate the center. Well, I wish it said describe the shape first. I'm going to do F first. I always think if you describe your shape first, you get a much better idea what the other answers should be. So as we've been doing, if I connect roughly the tops, whoa, that's clearly a tail, right? And the tail is pointing to the right, so this is going to be skewed right. All right, the reason why I like to do that one first is then when I find the center, instead of being a perfectionist and finding the exact middle, which you can if you'd like, you will get kind of a good approximation if you just take the cluster of the data, which is over here on the left, and just find the middle of that. So I'm going to go with roughly 20. Now remember, it's not exact. So if you said 25 or 30, those would all probably be okay. If you went with 10 or 40, I think you're getting a little bit too low or too high. All right, the spread. Oh, wait, maybe I should do it in this order. Sorry. The peak. So that's the tallest one, right? They had the most. So I think that's 10. Are there any outliers? You know, I kind of go back and forth. Sometimes when I teach this lesson, I have somebody give me a good argument that they want to call 70, 80, and 100 all outliers. Okay, sorry, I had a tiny human come in. So if you want to say 70, 80, and 100 are outliers, I could kind of get behind that. But I'm going to go personally with none, because the data kind of seems to trickle out over here, and there's a couple dots every now and again. So I don't know if any of them are really that far. There is a mathematical way where we would calculate it, but we're not going to get that specific. All right, the spread. So when we do the spread, we have to look at the context. This is about the number of text messages a kid sends per day. Some kids are sending 0 and 10, and some kids are sending 80 and 100. I would think that's a large spread in this situation, right? Large spread or large variability. Some kids don't even have a phone, it seems like, or they don't use text messaging at all. They use some other thing like Snapchat. All right, give a range of numbers where the data is clustered. So I had already kind of made this circle from 0 to 40. It does not need to be exactly the same. If you wanted to say 10 to 20, that would be fine. 10 to 40, anything around there would be great. Are there any gaps in the data? A little bit. There's a little bit of a gap between 50 and 70, and a little bit of a gap between 80 to 100. All right. Oh, I missed this one. I'm sorry. The range from our lesson last week, that's the highest number minus the smallest, or maximum minus minimum. So that's going to be 100. All right, moving on. We got our histogram. If you need to take a break because I'm being too boring, this is where you can pause, text your friends, and then jump back in, okay? All right. In September, 20 students and the teacher of a math class were surveyed to determine how many minutes a week they spent in the math DIC. The following data was collected. So we see all our numbers, and the first thing that catches my eye is they are not in order. So I need to be careful. You can put them in order if you want, but I'm not going to. I'm just going to be extra careful. So the first thing it says is complete the frequency table below. So this spot says tally, which my kindergarteners are learning about their tallies all the time. Tallies are when we do these things. Remember those? So that's what we're going to do, is we're going to make a tally for all these numbers. And so the way you do it so that you don't miss anybody is you go through each number in the data set and make the tally mark. So the first number is 0. Well, that falls in the first interval, 0 to 9. So I'm going to put a tally. 10. 10 falls between 10 and 19. 28. 30. I wish I already did it so that I could now just hit a fast forward button, but I don't have one. 18. 55. 25. And using this tally method is how you make sure you don't miscount. It is so easy to miscount when you're doing these. And hopefully I won't miscount while I'm doing it for you. Maybe you're doing it on your own right now, like you should be. All right, I'm getting there. 50, 0, 20, 10, and 40. Okay, I think I got them all. You could count them and double check. I will say there's a typo in the wording. It's not 20 students and a teacher. It's 19 students and a teacher, so there's 20 altogether. And I did count them. I paused it, and I made sure I didn't miss anybody. All right, then we have the frequency column. The frequency column is just where you add up your tallies. So I got a 3, an 8, a 4, a 1, a 2, and a 2. Okay, and again, you can count and make sure you add up. So you will see sometimes this column is missing when you have it on a worksheet. You can always make your own tally marks off to the side over here if that tally column, I should say, is missing, okay? All right, now we're gonna draw our histogram. So it says our first tip, label both axes. On the x-axis, you will always put the intervals. If you just write intervals, that's fine. If you want to say what the intervals represent, number of minutes, that's even better. On your y-axis, you are always going to write frequency. And if you want to put number of students, well, I guess it's student and teacher, right? So it might just say number of people. Frequency, number people. All right, now what we have to do is we have to decide how thick our bars should be. And this tip number 2 says the bars must touch. So you have to have the bars touching in a histogram. So we need 1, 2, 3, 4, 5, 6 bars. And if I had to guess, this probably is 20 long. And I think I'm good. So 20 divided by 6, let me think. Well, 20 divided by 5 is 4. So if I only needed 5 bars, I could make them 4 wide, but I need 6 bars. So I think I better make them only 3 wide. So this is going to be my first bar. And first I'm going to sketch it out and make sure it fits. So I'm going every 3 to see if I can fit my 6 bars. 1, 2, 3, 4, 5, 6. I think I'm good. So I like to turn my paper sideways, and I do 0 to 9, 10 to 19, 20 to 29. I hope you're writing nicer than me. 30 to 39, 40 to 49, and 50 to 59. All right, and then up the side, we look at our frequency, and our frequencies, the highest number we have is 8. So I think if we just count by 1, that should be fine. So this is 1, 2, 3, 4, 5. I'll mark here. 6, 7, 8, 9, 10. You could always count by 2 if you had room. We would not have had room for this one. All right, and then I think you got it from there, right? The first bar is 3 people high. So here's my first bar. My second bar is 8 people high. Yes, you could use a ruler, make it look beautiful if you wanted. The next one is 4. The next one is 1. And then we have a 2 and a 2. And it's not required, but I love shading them in like this. So feel free. All right, and there you have it. I did do step 3. I think I talked about it, but I didn't say it, or tip 3. The bars have to be the same width. So you can't make them 4 wide and then all of a sudden not have room and the last one's only 2 wide. It doesn't work that way. You got to make it look all the same. All right, and then from there, there could be some follow-up questions, just like we talked about at the beginning. The peak is in the interval 10 to 19. I think we could say the data is slightly skewed to the right. We could say the center is roughly around, oh gosh, I don't know, maybe 20 or so, 25, somewhere around there. We could answer all sorts of questions. All right, I'm over my 30-minute mark, so I am signing out. Good luck on your Delta Math assignment or your forms or your worksheet or whatever your teacher has given you. And we'll talk to you soon. Bye-bye.